the addition of a peroxy acid to an alkene. So in this reaction, we react an alkene with a peroxy acid. So a peroxy acid looks a lot like a carboxylic acid, just it has one extra oxygen atom. So we see that in the formula here as CO3H instead of what we are used to seeing, CO2H. A common peroxy acid that is used for this reaction is this structure here. This is metachloroperoxybenzoic acid, or as it's commonly known, MCPBA. So if you see the reagent MCPBA, you should recognize that this is a peroxy acid. And the reaction that you will see it doing this semester is to take an alkene and to form this cyclic ether, three-membered ring cyclic ether, which is an epoxide. Okay, the mechanism for this is one step. It is a concerted reaction. It takes place as shown here. You can see there are a lot of arrows here for this mechanism. Although I'm showing it to you here, you do not need to know this mechanism. So I will not expect you to reproduce this. Okay, the reason why I'm showing you the mechanism, though, is so that you can see that it takes place in one step, which means that there's no time for anything to rearrange, and that oxygen's transferred so it's on the same face of the alkene, right? So we see both of these as solid wedges. So where we can see the effect of this being a concerted mechanism is if we start with an alkene that has some stereochemistry. So if I start with trans 2-butene, and we react this with a common peroxy acid, MCPBA. So we know that we are going to have an alkene as our starting material, and we should get an epoxide as the product. Because this is a concerted mechanism, there's no time for any bonds to move around. So notice that these two alkyl groups are trans to each other. When we draw the product, they're still going to be trans to each other. So if we start this reaction with a trans alkene, reacting it with a peroxy acid, the product will be a trans epoxide. All right, so still trans because we have one group sticking up and one group sticking down. We can see a similar reaction if we were to start with a cis epoxide. It's still going to be a reaction that takes place all in one step. So nothing has time to rotate or move around. So when we get the epoxide product, if we start from the cis alkene, the epoxide product will be, so cis alkene, the product will be the cis epoxide.